Okay, lads, so what we're doing here is we're doing smaller and smaller squares, okay? So what happened here is that it's going inwards, continuing indefinitely, and then the next one will be like this, and the next one. So we're making smaller and smaller and smaller squares, okay? So the first thing we do is P1. P1 is 2, 2, and 2. So P1 equals 8. Okay, so P1 equals 8. That's the big one here. Okay. Next thing we're going to do is we're going to go for P2. Now what we can do next here is we can say that this is 1 and this is 1. We're looking to figure out what this is here, x. Okay. So 1, 1, and x. So x squared equals 1 squared plus 1 squared. Squared equals 2. X equals square root of 2. Okay. So now we have this one here, which is root 2, root 2, root 2, root 2. Okay. So when we do that, P2 ends up to be root 2, root 2, root 2. So P2 ends up to be 4 root 2. Okay. Next thing we're on then is P3. Try to figure out this here. Okay. Well, we know from here to here, we know that's root 2. Okay. So if we take this blue part here, this triangle here, we get root 2 over 2, root 2 over 2 equals x. Okay, so that'd be half of it. Okay, so we take here to here, it's root 2 over 2. So x squared equals root 2 over 2 squared plus root 2 over 2 squared. X squared equals 2 over 4 plus 2 over 4. X squared equals 1. X equals 1. So x equals 1, so that's 1, 1, 1, and 1. Therefore P3 is equal to 4. Now once we do that, what we're going to be left with is infinity. Definitely right. So to infinity. Okay, such that it's going to be 8 plus 4 root 2 plus 4 plus dot dot dot. So that's P1, P2, P3, P infinity. Same thing as T1, T2, T3, T infinity. Okay. So what we're going to say is that S infinity equals A bracket 1 minus R equals T2 over T1, R equals 4 root 2 over 8, which equals T3 over T2, which is the same thing as 4 over 4 root 2, and the answer is going to be 1 over root 2. 1 bracket root 2, 0.707, same thing as root 2 over 2. So 4 root 2 divided by 8, same thing. Okay, so S infinity equals A, which is 8, over 1 minus 1 over root 2. Put that into the calculator. 1 minus over root 2. We get 16 plus 8 root 2. And that's our answer. Happy days. Okay. 3. At the first stage of a pattern, a point moves 4 points from its original. Okay, so starts 4 points. So that is 4 plus, and then it moves 2 points, 2. 4 plus 2. And then what else? The first point, and then for example, the turns left moves 1. 4 plus 2 plus 1. Has to travel this far here. And then what we have here is 0.5, 0.5, 0.25, 0.125. Okay, so 1 plus 0.5 plus 0.25 plus 0.125. Okay, it's a geometric sequence. And we're trying to figure out how many stages has the point completed when the total distance traveled along the path is 7.9375 units. Right, so that's T1, T2, T3, T4, T5, T6, plus dot dot dot. Right, so A equals 4, R equals a half, Sn equals A bracket 1 minus Rn 1 minus R. Find N. Okay, so Sn equals A, which is 4, bracket 1 minus a half to the power of N, all over 1 minus a half. Now 1 minus a half is basically a half, and then 4 divided by a half equals 8. Okay, so what we're thinking here is that we can just get rid of this here and equals 8. Okay, now what we're going to do next is going to check this out using the table function. So our usual trick, 8 bracket 1 plus a half, so 1 minus a half to the power of N. To the power of N. Half to the power of X. To the power of X again. To the power of X. And then close bracket. Start at 1, end at 10. Let's see. So we have 4, which is a S1. S2 is 6. S3 is 7. And then stage 7. So it'll be N equals 7. We know that much. We gotta show it. Okay. So Sn, it says that has to complete your 7.9375 units. Okay, so 7.9375 equals 8 bracket 1 minus a half to the power of N. So divide by 8. So bring that underneath. Divide by 8. So 7.9375 divided by 8. 127 over 128. equals 1 minus a half to the power of n. Bring the 1 over the other side, so it's 127 over 128, take away 1 equals minus a half to the power of n. And then this will equal u equal minus 1 over 128 equals minus a half to the power of n. Multiply both sides by minus, so a half to the power of n equals 128. Okay. So this is 1 to the power of n divided by 2 to the power of n. You multiply the power top and bottom equals 1 over 128. 1 to the power of n equals 1. Doesn't matter what it is, it's always going to be 1. Okay, so it's 1 over 2 to the power of n equals 128. So it's safe to say that 2 to the power of n equals 128. And then n will equal, indeed you can shift fact that, so 128 shift fact, and you get 2 to the power of 7. Okay, so 2 to the power of 2 to the power of n equals that, so n equals 7. You also, back here, what you could have done back up here is you could have logged both sides if you really wanted. So you could have done any log of your choosing. So log 10 by a half to the power of n equals log 1 over 1 to a. Move the n to the front. N log 10 to the power of a half equals log 1 over 1 to a. And then what you could have done there is you got to divide them. So n equals log 1 over 1 to 8 divided by log a half. Put that into the calculator. We got log 1 over 1 to 8. And then divide that by log a half. Seven again. It once again equals 7. Now what am I dealing with next? Find the maximum distance point can move longest path with continuous path infinity. So it basically wants S infinity. S infinity is equal to A over 1 minus R. Our A value is A is 4, R is a half. 4 divided by 1 minus a half equals 4 divided by a half equals 8. So that's all we can do there. Now we're going to move on. Okay. Next part. Complete the second row of the table below showing the changes to in the x coordinates and the first 9 times the point moves to the new position. Hence, otherwise find the x coordinate and y coordinate of the final position as the point it's approaching if it continues indefinitely. Okay. So we might need our original diagram for this, so I'm just going to copy and paste this. So I'm just going to go back up here. Let's have a look at this. So okay. So what do we have here? Change in x, change in y. So it starts off at 0, 0. Starts off at 4, 0. Change in x is 4, change in y is 0. 0 up to 4, 2. That's 4, 2 is changing that, no, changing that 2. Okay. Then we went to minus 1, but we had 0 change in y. So every second turn is going to be 0. and every second turn here is going to be 0. Okay, so that's a good start off, okay, because it's halves every time. So this time, that is the second go. The third go over here, we drop down. So it's 4, 2, and then we drop a half, so minus a half, and then we go up to the next one, which is plus a quarter. So a change in x would be a quarter. And then we go across here. So it's going up. So it will be an 8. So it's like we're mirroring the image. And then so it's like being here. Up an 8. So we're going up an 8. Now we're going to spiral left a 16th, but it's left, so it's minus a 16th. And then we're going to go down 1 over 32, which would be minus 1 over 32. And then we're going to the right by 1 over 64, which is 1 over 64. Perfect. Now, starting off point. Okay, so what we need to do is we need to sum up the changes in x. Okay, so x is 4 minus 1 quarter minus a 16th 1 over 64 x. So that's x. So what we do is to get the sum of infinity, see how much we move overall. Alright, so x is this plus that one minus that one plus that one. Y. Okay, so we need to get sy plus dot dot dot. Y is 2 minus a half, and then it's plus an 8, minus 1 over 32 plus dot dot dot. Now we have an a value of 4 and an r value of minus a quarter. In this one we have an a value of 2 and an r value once again of minus a quarter. Okay, so we're going to find S affinity for both x and y to see how much they move from their original point. Okay, so what we're going to do next is S affinity. So S affinity is going to be a bracket 1 minus r. So this is going to be 4 over 1 minus a quarter. Is going to be equal to 3.2 or 16 over 5. The next one, which is for the y, is going to be 2 over 1 minus a quarter. And that equals 1.6 or 8 over 5. Okay, so we started at 0, 0. So it's going to be 0 plus 3.2 and 0 plus 1.6. So where we're going to end up is 3.2 and 1.6. So we move across 3.2 and up 1.6, which makes sense because you start here and you're pretty much going to end up somewhere over here at less than 4 and smaller than 2. So that makes a lot of sense. Okay, guys. So that's questions 2 and 3.